So molweni bafundi nani zimfundisi Ntsapho. So kule video yanamhlanje yethu sizojongana ne-organic chemistry, right? So kule lecture yethu into esizawujongana nayo yinto yokubana uba yintoni organic, zintoni organic molecules okokuqala. Okwesibini sizojongana uba zintoni organic molecular structures, and also sizojongana ne-UPAC naming formula zayo, guys. Okay, so okokuqala yintoni organic molecule, right? So its definition organic molecule, an organic molecule is a molecule that contains carbon atoms which generally it's bonded to other carbon atoms as well as hydrogen atoms. So lento ithi bana i-organic molecule zii-molecules apho khona kukho i-carbon atoms ezibonde ne-carbon atoms, also neentoni ezibonde ne-hydrogen atoms, guys. Right, ku-representation yethu yapha left siyabona ukuthi inantsika i-organic molecules zintoni zii-molecules ezibalulekileyo ebomini, because zintoni zithini zithathe inxaxheba ukuthini empilweni zethu, right? Ziformishe ii-molecules ezithini zakhe impilo zethu. Okokuqala zintoni ezi molecules? Ezi molecules ezifonyishe zi-hydrocarbons zezintoni zii-lipids, right? So inantsika i-carbon atom, so i-carbon atom it forms i-lipids, right? It forms i-backbone ye-lipids, guys. And i-lipids zintoni zii-biomolecules esinazo ebomini ezithi sibe nazo ebomini, right? Sinantoni futhi sine-proteins, right? I-proteins also zintoni zi-part of what of organic molecules esinazo ebomini bethu engapha phakathi empilweni, right? So sinantoni futhi sine-nucleic acid, which is i-DNA and RNA, which forms of part of i-organic molecules esinazo empilweni, right? And then sine-proteins, sine-nucleic acids, and then sine-carbohydrates, right? Carbohydrates zintoni zezinye zentoni ze-organic molecules esinazo empilweni, right? Carbohydrates zine-starch that give us energy, right? So yeah, guys, and also le nantsika le representation ebalulekile kuyazi, because le representation ibonakalisa ntoni? Ibonakalisa ii-monomers ze-starch uba yintoni zilawe, ibonakalisa ii-monomers ze-starch, right? Uba zii-monosaccharide. And then ibonakalisa ntoni? Ibonakalisa ii-monomers, ii-building blocks zantoni ze-nucleic acid, which is i-nucleotides. Iyabona apha zibonakalisiwe ii-nucleotides nazi, right? Inantsika i-nucleotide nazi, which means le iyellow yintoni i-phosphate group, le ingathi inantsika ibo-triangle apha inantsika i-blue yintoni i-sugar base, and then le pink apha ecaleni iba yi-nucleotide, right? So also we have i-monomer yenantsika ye-proteins bezintoni, which is i-amino acids. Amino acids are what? Zezi amino acids zenziwa zintoni? Ziza ne-transfer RNA from cytoplasm, but izawufika also stage apho khona ngicacisa khona loo nto. And then sine-lipids ke, guys. Lipids also form part of what? They form i-part yentoni ye-organic molecules esemzimbeni, right? The text ithi bana the organic compound are also used to make products such as medicine, plastics, washing powders, and dyes, along with a long list of other items. Yabo, nokuthi mina i-organic compounds are used for izizathu ezithile empilweni. So le nto ithini ba organic molecular structures, carbon has 4 valence electrons, which means that each carbon atom can form a maximum of 4 bonds with other atoms, right? So ukuthi i-carbon atom is an atomic carbon inantoni inokwenza ii-bonds ezintsha zibe yi-4 qha ngaphandle, inokwenza ii-bonds ezintsha zibe yi-4, not more than 4 bonds, right? So it says that the carbon can form bonds with other carbon atoms to form single bonds, double bonds, or triple bonds. So le nto icacisa ukuthi bana i-carbon atom can form i-single bonds, it can form i-double bonds ne-carbon atoms, it can form i-triple bonds ne-carbon atoms, because besesitshilo ngaphambili sathi into i-carbon atom it is what? besitshila ngaphambili sathi ntoni i-carbon atom has what ina 4 valence electrons, guys. 4 valence electrons. So meaning that the carbon atom can form what? It can form double bonds, it can form triple bonds, guys. So let's read this. It says, because of these long chain structures can form, this is known as catenation. The bonding of atoms of the same element into longer chains. It says these chains can either be unbranched or they can be branched and can contain single carbon to carbon bonds only, or double and triple carbon to carbon bonds as well, right? So kuthiwa apha kule nantsika kule information ifumana apha kuthiwa apha inantsika i-bonding of carbon to carbon apho khona zenza i-long chains ibizwa ngokuba ntoni? Ibizwa ngokuba i-catenation, guys. It's called catenation, right? I-catenation njena inantsika le as valence electrons ale carbon atom yenza kwaze ukuthini uba i-carbon atom ithini iforme inantsika double bonds between ezinye i-carbon atoms, and also iyakwazi uthini iformation ntoni i-single bonds and i-triple bonds between i-carbon atom nenye carbon atom, right? So siyabona apha lona kule representation i-carbon atom in a periodic table that ba sinikwe ntoni? Sinikwe i-atomic number, right? Sinikwe atomic number, guys. Atomic number ka carbon ngubani? ngu-4. Carbon atomic number ka carbon ngubani? ngu-6, guys. Ngu-6, meaning that the atomic number is the number of protons le carbon atom inazo, right? Siboniswa ntoni? Siboniswa ne-atomic mass yale carbon atom, and then saboniswa ntoni? Saboniswa ne-electronegativity le carbon atom, which is what? 2,5, guys. Yabo. So kubalekile uyazi ba okay i-atomic number ka carbon ngubani? ngu-6. And why is it called atomic number? It's called atomic number because inansika i-carbon is an atom inantoni? Ina 6 protons ngaphakathi and ibe nentoni? Ibe ne-6 neutrons, right? So la 6 mele number of protons ezintoni? Ezikwi-carbon atom or carbon nucleus, right? So le representation number B ibonisa noni? Ibonisa structural formulas. Basically niyenzekayo apha le nto izama ucacisa into yokubana ba i-carbon atom ibaluleke kakhulu entoni ebomini as a result that ba i-carbon atom forms intoni? Forms i-base okanye forms i-structure santoni? Forms i-structure se-molecules ezininzi ebomini, right? Like umzekelo i-glucose is formed by what? It's formed by carbon atom, meaning that ba if umzekelo ibingekho glucose besingekwazi nokwazi usurvive because i-energy esinayo ngoba sifumana phi? Sifumana kwi-glucose, you understand? So yeah, guys, this is how important it is in photosynthesis, right? It says that carbon atom has an atomic number of 6, indicating the 6 protons in the nucleus, which leben mesele icacisile ngaphambili uba u6 bonisa ntoni? U6 bonisa i-protons, which is atomic number, right? So it says, like, think for example of a carbon to carbon bond. It says the difference in electronegativity between the two atoms is 0. So this is a pure covalent bond. In the case of carbon to hydrogen bond, the difference is in the electronegativity between the carbon is 2.5 and hydrogen is 2,2. It is so small that the CH bonds are almost purely covalent. The result of this is that most organic compounds are non-polar. This affects some of the properties of the organic compound, right? So then we take to like as carbon to carbon bonds, like good carbon to carbon bonds is electronegativity that bar 2,5 electronegativity carbon atom. So when two carbon atoms they bond, electronegativity was 0 because they have the same energy. They have the same energy as two carbon atoms. Sifuna ngokulingana lezi endoni as electrons. right? So meaning that but there's gonna be a balance between energy levels of one carbon atom to the next, because they have the same electronegativity, right? Unlike upper corner where a carbon has bonded with hydrogen, right? So hydrogen has less electronegativity as compared to carbon, meaning that carbon will want electron more than hydrogen atom. Loo nto leyo yenze ukuthini, yenze kubekho inner polarity. Loo nto yenze kubekho inner polarity atoms ezininzi, which means that there's gonna be side kule atom as atoms bondileyo that is more positive, and then there's gonna be a side in the atom as atoms bondileyo that is gonna be more negative. So the binding characteristic says the valence electron, carbon has 4 valence electron in the outer shell and obvious shell, which are the tetravalent nature. Carbon readily forms 4 covalent bonds, allowing it to create a stable molecule by sharing electrons with other atoms. This tetravalency is a key nature in organic chemistry. Like the fact that the carbon has 4 valence electrons, and le nto leyo yenza ukuthini ibe able to form double bonds, triple bonds nezinye atoms, right? Which means naloo nto leyo the fact that carbon has ungakwazi ukubonda with 4 other carbon atoms iye ithini ibe nomthelela kwi-characteristics zaloni ibe nomthelela kwi-characteristics eziyezifonywe zine carbon atom, and also in those other carbon and also those other atoms, right? Because nesanguyicacisa ngabo kanye uNansiko oyinyuse that carbon atom is the most important atom ekhoyo, right? Because it can form as many bonds as possible, and it can make a chain and belite, and also while making the chain long, it can also bond with other atoms, meaning that there's a more possibility of new combinations of atoms. So that the role in life molecules, the carbon is a crucial element in biomolecules, organic compounds in living organisms such as proteins, organic molecules in living organisms such as proteins, nucleic acids, lipids, and carbohydrates all contain carbon atom. So they all contain a carbon atom, guys. You see, so that's why it's very important about meaning a carbon atom. So now let's look at the sources of carbon atom. The sources of carbon atom, it's found where the main source of carbon atom is in organic compounds, is carbon dioxide in the atmosphere. Okay, the main source of carbon in organic compounds is carbon dioxide in the atmosphere, right? The plants use sunlight to convert carbon dioxide and water into sugar through the process of photosynthesis, right? So indlela apho khona ii-plants zifumana ngayo carbon is through the process photosynthesis, apho khona ii-plants zithatha amanzi ne-sunlight ne-carbon dioxide kwi-atmosphere, and then zenze i-oxygen as a byproduct, and also zenze ukutya opposite sokutya, which means i-glucose ngamafutshane, yabo. So i-process photosynthesis ibaluleke kakhulu, guys. So plants are therefore able to make their organic compounds through photosynthesis, while animals feed on plants plant products to gain organic compounds that they need to survive, right? So in essence, consumers, basically we animals, what we do is that we consume the energy that is being generated by plants, right? So plants basically singathi in a scientific terms autotrophs, right? i-branch zindoni zi-autotrophs, guys, which means they create their own food. And then indoni animals indoni zi-heterotrophs. Right, because in the esenzayo we cannot generate our own food. Esenzayo thina is that we consume qha, yabo. So and on also kunansi ku left yakho uzobona ukuthi we have what, we have our representation, of what, we have our representation of a photosynthesis. Apha siyabona nansi photosynthesis nansi equation yayo, yabo. Apho khona to find that but there's 6 molecules ka carbon. There's 6 molecules of carbon that is bonding with what, with another 6 molecules zamanzi that makes what, that makes glucose, and also 6 molecules is oxygen that ithini iye iphume through the stomata, guys. Okay, so it says that bana hydrocarbons carbon form what hydrocarbons. It bana carbon forms the basis of hydrocarbons, which include alkanes, and alkynes. These compounds are foundational in organic chemistry, right? So bazabucacisa into yokubana up again that bana carbon forms the basis in hydrocarbons. Apho khona hydrocarbons will make alkanes, alkenes, and also make alkynes, right? So the alkenes are what? So alkenes is these organic molecules that are what? The organic molecules that are what? Double bonded, right? So alkenes, the organic molecules that are double bonded. Let me highlight. So these ones are double bonded, and then the alkynes is the molecules that are what? So organic molecules that are triple bonded, and then indoni alkanes, the organic molecules that are what? That are single bonded. They have single strands. Yabo. So yeah, guys, this is trying to illustrate that by carbon it's very important, and also it forms in Antica the backbone of a functionality hydrocarbons, which means that by the example the is different hydrocarbons that we have, which is alkanes, and alkynes, guys. So this it means there are 4 ways of representing a compound in 2 dimensions. It's a structural formula. And then the structural formula of an organic compound shows every bond between every atom in the molecule. Each bond is represented by a line, right? So this means that by the A, it's a what? This is a what? Then is structural formula. Ska 2 methyl propane. Right, 2 methyl propane. So this structural formulas sibonakalisa ndoni bonds between carbon atoms, and also between what? Between hydrogen atoms. And these bonds sibonakalisa ngeline, guys. You understand? So each and every time there's always structural formula funeka uyazi bana uzozibonakalisa zonke bonds zakho between the carbon to carbon atoms, and also between the carbon to hydrogen atoms, right? And then spend a second example here to number B. Upper corner, this is what? This is butane. Right, this is butane, guys. Butane engineer is what? It has 4 carbon atoms, 1, 2, 3, 4. Right, so it's very important as Babin Chilanga Pamela that to show the what? To show what you call, to show bonds between the carbon atoms and also between the hydrogen atoms, and you show them by what? By drawing and let's spend a semi-structural formula. So a semi-structural formula now it says that it is possible to understand the structure of an organic molecule without writing out all the carbon hydrogen bonds. This way of writing a structure is called semi-structural formula. So semi-structural formulas on this bonakalisayo apha zinoni bonds between what? Between the carbon atoms. As born now, this is the bond between this carbon atom. We show a line, and the bond between this carbon atom and this one, we to show a line. We need, so what is the same structural formula, right? Then the second example, this is what the example ka 2-methyl propane, and then this is example about butane besibonisa ngaphambili. You see, so instead of basibonakalise also in the hydrogen bonds as carbon atom, you are only focusing on what sibonakalise ilawi atoms, ilawi bonds that are between what carbon atoms only, and then last in the hydrogen atoms, we just subscript 3, and then indicating how many hydrogen atoms as carbon atom. You see, like lapha sina CH2, which means H2 represent hydrogen atoms ezibone carbon atom, without showing what ngaphandle kubana sibonise umugca okanye sibonise le bond yethu njengaphambilana. You understand? So yeah guys, this is simple. You should be good in this, right? So inansi kumzekelo wesithathu sibonisa i-2D format yethu structure hydrocarbons kukuthini kokubonisa i-condensed structural formulas, right? So i-condensed structural formulas zona enywenzekayo kuzo abonisa into eninzi. Into ebonisayo is just that zeziphi carbon atoms ezikhoyo. Like umzekelo kula 2-methyl propane siyabona ukuthi no, we still do have 3 carbon atoms, 1, 2, 3, right? Njengoba zi-3 carbon atoms, we also have a substituent, that is what ibonakaliswe kwi-carbon atom yesibini. Answer the substituent guys, it's in brackets, right? The substituent in brackets nje nebonakalisa ba kwi-brackets the substituent okanye the branch chain, and also ibonakaliswe phambi kwe-carbon atom yesibini, meaning that ba nje ibonakaliswe phambi kwe-carbon atom yesibini, the substituent is bonded to a second carbon atom. Yabo. So yeah guys, so it's CH3 CH, and then ke ngokube ku bracket with substituent yakho, and then CH3 again, right? So as been CGT condensed structural formulas awubonisi bonds at all. Unenzekayo qana, you just draw your carbon atoms and their hydrogen atoms close to each other, and also bonakalise ntoni, bonakalise substituent yakho bendawoni ibonde kwephi carbon atom, and also kufuneka uyifake phakathi kwi-bracket ukuze loo nto kumakisha yakubona okay no lo mntu azama izoba apha okanye izama ibhala ntoni yi-substituent okanye yi-branch chain, right? So let's go to number B. On number B, as babensitsho, we have unantsika ilawe i-butane, and butane nayo sibonakalise apha ntoni, sibonakalisa apha what you call, sibonakalisa ilawe i-condensed structural formula saso, right? Sibonakalisa ngoba sifake ntoni i-hydrogen, nantsika bonds between carbon atoms and also between hydrogen atoms, right? So yeah guys, this is how easy it is. Condensing apha kangaka, yabo. So it says that it is also possible to represent a molecule without showing any bonds between atoms at all. This is called a condensed structural formula, guys. This is called a condensed structural formula, right? It says that the branched or the substituent group are shown in brackets after the carbon atom to which they are bonded to, right? It is what something it is each branched or substituent groups are shown in brackets. They are shown in where? In brackets. What? Branched or substituent groups, they are shown in what? In brackets. And abayenze apha bayibonise le substituent group guys in brackets, and that's the substituent group ikwi brackets nayo. You understand? That's the substituent group ikwi brackets. Right. So let's go to another example. Let's go to a molecular formula, the last one. The last representation and get to deformate hydrocarbons in molecular formula, right? So it says that molecular formula of a compound shows how many how many atoms of each type are in the in molecule. The number of each atom is written as a subscript after the atomic symbol. Right, it says that but the molecular formula of 2-methyl propane is what? It's C4H10. Right, it says but this means that each molecule of 2-methyl propane consists of 4 carbon atoms. This means that each molecule of 2-methyl propane consists of 4 carbon atoms and 10 hydrogen atoms. Right, so le nto ithetha ukuthini le molecular formula yona all into ezayo iyi-1 kubonakalisa uba zingaphi carbon atoms ezikhona kwi-specific atom. Like umzekelo here we are given example yantoni, we are given example ka 2-methyl propane. 2-methyl propane, right? So 2-methyl propane, they've shown example here a molecular formula yakhe C4H10, right? And then ibonakalisa ntoni, kubonakalisa how many carbon atoms are there and also how many hydrogen atoms are there, guys. So that's how easy this is. That's how easy this is. And in TK40, this means that each molecule of 2-methyl propane of 2-methyl propane consists of 4 carbon atoms and 10 hydrogen atoms. And it the molecular formula of butane is also C4H10. Right, the molecular formula gives no structural information, about the compound. Right, so a molecular formula I won't say anything about the structural formula. It only focuses on what? It only focuses on in number of carbon atoms. So can in number of atoms per what? Per atom. Ibonakala zingapi uyabo, like umzekelo how many carbon atoms how many carbon atoms eziku 2-methyl propane okanye how many hydrogen atoms eziku methyl propane njalo njalo, guys. So guys, if you reached the party of this video, meaning that you have reached the end of the video yam, thank you very much for ukubukela le video ezibandizama nami and also at my peers university to assist abantu baka grade 12 okanye abana base high school with science and also with maths. So guys, please if bamzekelo ufuna ngeSixhosa i-science, maths and physics, please subscribe kule channel so that sizokwazi uncedana and nawe uzokwazi uthini to succeed and come up with marks ezinhle upass grade 12 kakuhle and fulfill your dreams. Okay, so yeah guys, inkosi kakhulu ngokubukela le video. Please subscribe to my channel if bayayithanda le channel okanye it brings value ebomini bakho, and also like the video and njalo njalo, guys. Inkosi kakhulu.
I think you captured it very well. There is no any better explanation than the explanation you have given.